Hello, welcome to lesson 4.3. So, hopefully by now, you're starting to feel comfortable solving equations. Because what we're going to start doing is now we're going to start seeing equations with variables on both sides. So we're going to have an x on both sides of the equal sign, or a y on both sides. So if you imagine like 3x plus 5 equals 2x minus 8, whatever. And our goal is the same. Our goal is to get the variable by itself. So we want to have, in the end of this, x equals some number. Okay, that's going to be our goal, and we're going to get there. This lesson, we're going to use all 5 steps of the solving equations method. So let's get into it. So the central question says, how do I solve equations with variables on both sides? It's pretty straightforward. And for our warm-up here, it is a type 1. You have 2 minutes on the clock, and it says, when using the distributive property, why do you multiply by both numbers in the parentheses instead of just the first one? So I gave an example here so you can think about that. So why do you take this 5 times by this and times by this instead of just 5 times the first one? And another way to think about this, if I just take out the x, if I have this, why would we multiply by both the numbers in the parentheses instead of just the first one? So think about your response, maybe do a test on the side of a sheet of paper or something like that, and then write your answer. Pause the video if you need the time a little bit longer, take 2 minutes. When you're ready to continue to the vocabulary, hit play, and we'll move on. So, in our vocabulary box, we just have this one thing that says solving an equation, and it gives us our 5 steps. Now, you may be familiar with 4 of the 5 steps by now, and you can probably guess what the other step is. So let's start at the top and work our way down and fill in these steps. So the first step here in solving an equation, step number 1, is we want to get rid of the parentheses by distributing. Okay, so we get rid of these parentheses by distributing. The next step is we try to combine like terms on each side. And if you remember from the previous lesson, these first 2 steps basically come down to simplify each side. So you make each side as simple as you can before you start solving, just to make your life easier, make there's less stuff to have to worry about. So that's basically what those first 2 steps come down to. Step number 3. So once you've got rid of your parentheses and you simplified each side as much as you can, well, we'll skip step 3 for a second. Step 4, we remember from the previous lesson, was to get rid of the other terms by adding and subtracting. And the last step is always the last step, is to get rid of the multiplies and divides. Get rid of these coefficients. And that's always using your multiply and divide. Alright, so step 3, the step we skipped, the new step for today, you could probably guess since the title of the lesson is solving equations with variables on both sides, is we've got to do something if we have a variable on both sides of the equal sign. Now, what I'm going to list here as a rule is more of just, it's not a rule. It's not something you have to follow religiously. It's more of just how I do it, and a lot of students find it easier. So I'm going to say here, get rid of the variable on the right side of the equal sign. So if there's a variable on both sides, get rid of the one on the right. And I would like to mention here, this means if it's the same variable on both sides. If you have two x's or two y's. If you have an x and a y, which we'll be talking about later this module, this one kind of doesn't really apply. So get rid of the variable on the right. And that's simply because most people like having the variable on the left-hand side of the problem. They like having like x equals 5 instead of 5 equals x. And if you do the problem the same way each time, it becomes familiar, it's easier to do. So there's absolutely nothing wrong with getting rid of the variable on the left. In fact, sometimes I might do that simply because it's easier, makes the problem simpler in the future. But getting rid of the problem or the variable on the right or the left doesn't make a difference. You basically just want to get rid of one of your variables. Usually the one on the right is the one that I do, though. So here we go. Let me see. Add, subtract, multiply, divide, distribute, and combine like terms. Those are kind of your keywords. So you distribute, combine like terms, get rid of the variable on the right, add and subtract, multiply, and divide. Here we go. So solving equations with variables on both sides. The first problem here says 14k plus 55 equals 11k plus 94. So I'm going to separate my two sides. I check each side. The left side, there's nothing to simplify. There are no parentheses. There's no like terms. On the right side, there's no parentheses. There's no like terms. So my first two steps are already done. There's no simplifying needed. Step 3. If you have variables on both sides of the problems, which we do, get rid of the variable on the right. So for me to get rid of this piece here, I want this whole term to go away. Anytime you want an entire term to go away, it's always going to be adding or subtracting. So this 11k is positive. So to make this thing go away, to go to 0, I have to subtract 11k. And on the other side, so this 11k minus 11k is gone, that whole term. And I'm left with a 94, and I still have my 55, it's positive, and this math gives me 3k. Now if you look at that, that looks like an equation from the last lesson. We have one variable. This is what's actually called a two-step equation. It's going to take 2 steps to solve this. We're going to get rid of the add and subtract. Then we're going to get rid of the multiply and divide, and we'll be done. So, minus 55 on both sides. These cancel out. Minus 55 here as well, giving me 3k equals, let's see, we can do the math in our head here. 8 carry the 1, that gives me 9, that gives me 3. And then divide by 3 on both sides to get rid of the multiply by 3. Cancels, and I have k equals 13. So I believe the answer is 13. Now it asks us to check our solution. So to check the solution, you simply plug the number back in. So 14 times by 13 plus 55 equals 11 times by 13 plus 94. And all we're checking to do is we want to see, does this side equal this side? If it does, then that is our solution. Okay, Mr. Calculator is going to help us out with some math here. So we're going to do 14 times by 13, 182 plus 55 equals 11 times by 13. I feel like I should know that one, but I don't. 11 times by 13, 143 plus 94. And then we still want to know, are the two sides the same? So I'm going to add this up and add that up and see what we get. So I'll do this side first. Since I already have 143 in the calculator, plus 94 equals 237. And then the 182 plus 55 equals 237. So this is the correct answer. That's how we can tell. By the way, remember I said the checking of the solution works really well if it's a multiple choice question? Imagine you're given a problem similar to this. Or, here, let's pull letter B out here. There's letter B. Imagine on like a PSSA test or something, they give you this question and they say your choices are either A, B, C, or D, and it could be like 3, 8, 5, or 12. Now, you could go through and you could solve this problem like normal. By the way, I don't know if any of these 4 answers are correct. I just made them up off the top of my head. But you could go through and you could solve the equations like we just did in example A and get your solution. Or you might find it easier to just go through and check each of these solutions. If you plug in 3 for the M here and the M here and see, does this side equal that side? If it does, then that's your solution. So that's why I said earlier that the checking of the solutions can be really helpful in a multiple choice question because it might save you a lot of time. If you forget how to solve an equation for some reason, boom, you can go through and plug them in, and all that has to be true is both sides have to be equal, and then you know you're guaranteed that that is the correct answer. So let's see what the answer actually is. We're going to solve the equation. So on the left side, there is some simplifying I can do. I can distribute here. I'm going to take 2 times m and 2 times 5, giving me 2m plus 10, and on the other side, there's nothing to do, so 4m plus 17. All right, step 3. We're going to get rid of the variable on the right. So I have 2m, 4m. Now, this is an example of a time where I personally, if I was doing this on my own, I would actually get rid of the variable on the left. Simply because if I would, I'll change color here just to show, if I would subtract 2m and minus 2m, these would cancel out and this would give me a positive 2m. But the way we're going to do it is if you get rid of the variable on the right and minus 4m on each side, on the left-hand side, we're going to get a negative 2m. And some people don't like negatives and they find them harder to do, so some people just don't do them. But that's really the only reason why I would get rid of the 2m instead of the 4m. Just to avoid this negative there. But it's the same difficulty of problem, probably. So let's go. So we're going to get rid of the add and subtract before the multiply or divide. So I'm going to minus 10 on each side, giving me negative 2m equals 7. Divide both sides by negative 2. And I get m equals a negative 7 over 2. And we can actually simplify that. Let's see, 2 goes into 7 3.5 times, so negative 3.5, or you can use a fraction 3.5. Okay, so we think that's the correct answer. Let's check. I don't need to. So let's see. 2 times by negative 3.5. Ooh, missed my plus sign. Plus 5 equals 4 times negative 3.5 plus 17. Alright, so let's see. Negative 3.5 plus 5 gives me 1.5. And 1.5 times by 2 is equal to 3. So this side is equal to 3. Hopefully, this side is the same. 4 times by negative 3.5 is going to be negative 14, I believe. 4 times by 3.5 negative equals, there it is, negative 14. And then if you add 17 to that, you get the answer of 3. So the two sides are the same, which means, yep, that is the correct answer. So we solved the equation, we checked our solution, that's it. Now, one thing I hear a lot of students say is, that was a lot of work. And my answer to them is, it's a lot of little steps, but none of the steps are really terribly complicated. It's not hard work, it's just a lot of little easy work. Alright, letter C. Separate your two sides. Nothing to simplify on the left. Nothing to simplify on the right. So there's no parentheses, there's no combining like terms. I do have variables on both sides, so let's get rid of the one on the right. Minus 10n, minus 10n. These cancel. And by the way, since I'm thinking about it, and I thought about the last problem too, you're not always going to subtract this thing. It just so happens that in these problems, I guess I should have one where this number out front is a negative. If this was, say, negative 10n, just to show, what you'd have to do to get rid of this is you would not subtract 10 anymore. That would be wrong, because negative 10 minus 10 does not equal 0. Because this would be a negative, you'd have to use a positive or a plus 10 to get rid of it. So those same kind of rules apply. You're still doing the opposite of what you see. So if it's a negative, use a positive. If it's multiply, use divide, that sort of thing. But I just wanted to show, because in all the examples so far, we've always just done minus this piece. Well, we're minusing it because it's a positive. If it was a negative, we'd have to add. So, continuing on, so we have our minus 10n, gives me 13 over here, our negative 5 over here, and this math equals negative 3n. Okie dokie, then we're going to add 5 to both sides, giving me negative 3n equals 18. I added 5 to get rid of the minus 5. And let's see, negative 3n equals 18. I need to divide by negative 3. And n equals negative 6. Let's see if I can check this one in my head. 10 times negative 6 is negative 60. And negative 60 plus 13, that's a little bit more complicated. Negative 60 plus 13, the signs are different, you have to subtract. You're going to get a negative 47. Over here, 7 times by negative 6 is negative 42, and negative 42 minus 5 is negative 47. So this checks out. That is our solution. Oopsie. Letter D. Ooh, isn't he pretty? So we have some parentheses in there. We have some fractions in there. We'll be doing some distributing. Give us some space here. So here we go. Separate your two sides. I can distribute here. So let's do that. I just start the easier side. So we got 5n, and 5 times 2 is 10. And I can distribute here. 3/5 times by 5. Now, remember, when you multiply fractions, make everything a fraction. So 5 over 1, 10n over 1. So 3 times 5 is 15. 5 times 1 is 5. 15 over 5 is just equal to 3. Okay, 3 times 10n is 30n. 5 times 1 is 5, and 30 divided by 5 is 6n. So that wasn't that bad. Just make your numbers fractions and do your multiplication. Our fractions are actually gone after we distribute, which is awesome. And then we can go through and we can solve this now. So let's see. I don't see any more simplifying I have to do. There's no combining like terms. There's no more distributing. So I have variables on both sides. Get rid of the one on the right. So I'm going to subtract 5n because it's a positive, and minus 5n here. 3 plus 1n. Remember, you don't need the 1 if it's in front of the variable. 1n equals 10. The variable is being added by 3, so I'm going to get rid of this term by subtracting it. Minus 3, and n equals 7. So that problem, there wasn't even a multiply to get rid of. Now, I've seen some students do this, and it's not wrong, but I just wanted to show you that it's not really needed. So if they said, okay, that's 1n, and they carry their 1 down, and then to get rid of this 1, they divide by 1, which doesn't actually work because 1 divided by 1 is still 1, but it makes them feel better. And then when you take 7 divided by 1 here, you still get n equals 7. So I'm kind of showing you that this extra 1 thing is not needed. You still get the same answer. The work is still the same. All right, so let's check our answer. I'll move everything over here. So let's get rid of these two. Take this whole thingy and slide them this way. That's all right. You can come along too. All right, so checking our work. So we got 3/5 times by 5 plus 10 times 7 equals 5 times 7 plus 2. I'm going to do the right side first just so it's easier. 7 plus 2 is 9. 9 times by 5 is 45. So my hope is that this stuff over here equals 45. Let's see. I'm going to worry about that fraction thing last. I'm going to do the math inside the parentheses, doing the order of operations. So 10 times 7 is 70, plus 5 gives me 75. So 3/5 of 75, I can turn into a fraction. 3 times 75 is 225, I want to say. 3 times 75 equals 225, and divide that thing by 5. Yepers. So 3 times 75 is the 225, and 5 over 1 is 5. And I simplified this. That's why I did the 225 divided by 5. And I did get 45 for an answer. So this answer checks out. That is correct. N equals 7. Okay. So that's the essence of solving equations with the variables on both sides. You have it's basically the same thing as the last lesson. You're simplifying to do the distributive property and the combining like terms. You still have getting rid of add and subtract, multiply and divide. We just have this extra one little step in here of if there's a variable on both sides, get rid of the one on the right. So I have a few problems for you to try. Go ahead and pause the video. Try these problems on your own right now. When you're ready to continue, hit play, and we'll go through them together. All right, so let's see here. Let's change color. I'll use black. No simplify. No simplify because there's no parentheses, there's no like terms. Get rid of the variable on the right. So I'm going to minus 7k on both sides. These cancel out. This gives me negative 2k minus 8 equals 13. All right, and now we're going to get the multiply last, so this subtraction comes first. So we add 8 to both sides, gives me negative 2k. You're gone. And that is 21. Divide both sides by negative 2, and we have k equals, that doesn't simplify, so 21 over negative 2, or that equals negative 10.5. And if you checked your work, I believe that would be true. I'm going to save the checking the work for a little bit just to save some time in the video. Feel free to check the work on your own, plug it into a calculator, do the math. But for these next few, I'm not going to check it up here. But have faith that we're correct. Check it for yourself. Prove me wrong. I've been wrong before. I'll be wrong again. So let's see. There's no parentheses. There's no parentheses. No combining like terms. No combining like terms. All right. I do have variables on both sides, so I'm going to get rid of the one on the right. Subtract 8b. This gives me negative 6b. This cancels out. Plus 9, minus 9. All right. Getting rid of this negative 6 will be last, so getting rid of this plus 9 will be first. Minus 9 on both sides. Negative 6b equals negative 18. Divide both sides by negative 6, and b equals 3. Letter G. Let's see, I'm going to distribute here. 3 times h is 3h, 3 times 5 is 15, and h plus 5 here. There's no more parentheses. There's no combining like terms. I do have variables on both sides, so I'm going to subtract 3h here. He's gone. Subtract 3h here. So remember, how many h's are here? 1. So 1 minus 3 is -2. And I'm going to subtract 5 on both sides, getting rid of the add and subtract before the multiply and divide. Divide by -2, and h equals -5. Lastly, letter H. Let's see. I'm checking the right side first, simply because it looks simpler, but I don't see anything to do. On the left side, we can distribute here. Half of 8 is 4c. Half of 16 is 8. Nothing else to simplify. So now we start getting rid of variables. So I've got variable on both sides. Get rid of the one on the right. Minus 7c, minus 7c. Then we negative 3c. Everything else just comes along for the ride. Getting rid of the negative 3 will be last. So getting rid of this minus 8 will be first. Add 8 to both sides. Negative 3c equals 24. And then divide by negative 3 on both sides. C equals -8. So that, in essence, is all there is to solving pretty much any equation problem you're going to come up against. These are the skills that are needed when you get variables on both sides and big, nasty, ugly equations. It's still the same basic steps. Speaking of big, nasty, ugly problems, whenever you have variables on both sides of the equal sign, there are some funky things that can happen, because there is the possibility that the variables will completely cancel out on both sides and they're gone. And those have kind of special solutions, special answers. So far what we've seen in every single one of our problems, every single problem has had one answer. There was 3.5, there was 7, there was, got rid of the other 2. There's 10.5, there's 3, there's -5, -8. We've always had one solution. We're going to start to see now what happens when these variables cancel out. What kinds of solutions can we get then? So let's start with this first one, letter A. I'll change back to blue. So if I start by distributing, normal method, 10x plus 5. On this side, we have 10x plus 2. Okay, there's nothing else to simplify. I've got variables on both sides. If I get rid of the one on the right, minus 10x minus 10x. These cancel. Over here, like I said, these are going to cancel as well. Now, it just is a coincidence that they cancel. Don't think that every single time you do an equation from now on, the variables are going to cancel, because it's not true. Just solve the equation like we have been doing, and if it cancels, just know that it's one of these special solutions. So in this case, we have the answer of 5 equals 2. And you ask yourself, does 5 equal 2? No. 5 obviously does not equal 2. So this problem, we say, has no solution. There is no answer to this problem. There is not a single number you could plug in for the x to make the left side equal the right side. Well, how do you know that? How can you be sure? Well, let me show you. If I go through and distribute this again, we had 10x plus 5, and this side was 10x plus 2. So I want you to think of any number right now, and if you plug it in for x, so think of a number and multiply it by 10. So my imaginary number is going to be 3. So if I take 3 and times by 10, I get 30. Now, can you take that number and add 5 and add 2 and get the same thing? No. On one side, you're adding 5 to 30. On the other side, you're adding 2 to 30. It doesn't work. You go, well, maybe you just picked a bad number. No, pick any number. Try 10. 10 times 10 is 100. 100 plus 5 and 100 plus 2. You're never going to get the same thing. So this equation has no solution because there's nothing that will ever make one side equal to the other. And we know it had one of these special solutions because the variables canceled out on each side. When we subtracted 10x, we got 5 equals 2. So that's the first special solution. It's called no solution. Letter B. Same thing. I'm just going to solve the equation like normal, because later on what's going to happen is you're going to see problems that say solve the equation if possible. So there will be some that you won't be able to solve, like these, and there'll be some that you can solve, like the ones we saw previously. So let's see. I'm going to distribute negative 8 plus 12x, and over here 12x minus 8. I've got variables on both sides, so I subtract 12x on both sides. These cancel out, these cancel out, and we have negative 8 equals negative 8. This is the other type of special solution. This one is not no solution because here we said, well, does 5 equal 2? No. Over here, does negative 8 equal negative 8? Yeah. This has the solution of, we call it all real numbers. Because what we have here, these real numbers, by the way, are just kind of like every number we use. Decimals, fractions, whole numbers, irrationals, rationals, everything. So pretty much every number is a solution to this problem. And here's why. If we go back to this second step, so I'm going to erase some of this stuff, just like I did in the previous problem. If we go back to the second step, we had negative 8 plus 12x and 12x minus 8. Look at these two sides. You have a positive 12x, positive 12x. Negative 8, negative 8. The two sides are identical. So no matter what you do to the one side, if you plugged in, say, a 3 here, like we did in the previous example, so 3 times 12 is 36. 3 times 12 is 36. If you take 36 minus 8, you get an answer. If you take 36 minus 8, you get the same answer. Because these two sides of this equation are mirror images of each other, you're always going to get the same thing because you're doing the same math on both sides of the equal sign. So that's why we say this problem has all real numbers as a solution. Every number, no matter what number you pick 5, it's an answer. You pick 12, it's an answer. You pick 2.36589, it's an answer. Every single number will work in this problem, letter B. And the way you can tell, just so over here, when we got rid of our variable, this was 5 equals 2. That does not work. It's no solution. Here, when our variables canceled out, we got 8 equals 8. That is true, so we have all real numbers. That's the way you can kind of remember how it works. So letter C. Distribute 28c plus 8 and 28c minus 5. The variables are going to cancel out on both sides. If I minus 28c here, further down, this gives us, well, 0, gone, 0, gone, 8 equals negative 5. So does 8 equal negative 5? No. This is no solution. And by the way, this is the answer, not this. That is not the solution. That is the evidence that tells you what the answer is. But the answer is there is no solution. That is the answer. Okay, letter D. Distribute 12g minus 6, 12g plus 6. We subtract 12g on both sides. We have cancels here, 6 equals 6. Now, I have purposely made a mistake. I want you to see if you can find the mistake, because this is a mistake I see quite often in class. And students would do exactly what I did and go, okay, oh, this guy's all real numbers. Why isn't it? And the answer to the riddle is this guy right there. This is a -6. But down here, you don't have the negative anymore. It should still be negative, even though this 12g is gone. Some people think of this as a subtraction sign and say, well, if there's nothing to subtract it from, it kind of goes away. No, it is a -6. So now we can say, no, this is not all real numbers, because 6 does not equal -6. This is no solution. Okay? So that's the essence of these special solutions. It's either no solution or all real numbers. You know the difference because no solution, when you solve the equation and your variables cancel out, your solution you get is not true. 5 equals 2, 8 equals -5, 6 equals -6. Those don't work, so it's no solution. It's all real numbers if when your variables cancel out, you have something like 8 equals 8, something that is true. All right, here's 4 for you to try on your own. So what I'd like you to do, go ahead and pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through them together.
So let's see how we did. So on this side, we're going to distribute, giving us 3x plus 9. And on the other side, we have 3x plus 9. Okay, that's pretty straightforward. Both sides of our equation are identical, 100% the same, which means this is going to be all real numbers. And we could actually stop right here because both sides are 100% identical. Now, some people don't like to stop here. Some will continue on and get the variables on the same side. So why not? Let's see what happens. So if you don't see that they're identical and you just kind of keep going, to get rid of the variable on the right, we would subtract 3x on both sides. That cancels. That one would also cancel. And we got 9 equals 9. So our variables cancel out on both sides. And our final answer, we got something that is true, 9 equals 9. That's another way to see the answer to this problem is every number is an answer, all real numbers.
All right, letter F. 5x plus 3x is 8x. 2 times 4x is 8x. And to be honest with you, you could actually stop right here. You could say, oh, the two sides are identical, so no matter what I plug in for x on one side, it's the same on the other. These sides will always be the same, so this guy would be all real numbers. Oh, that was bad. There. But some people like to go the step farther because they like to finish the problem and get rid of the variables on both sides. So if you would subtract 8x on both sides, this side gives you 0, this side gives you 0, and yes, 0 equals 0. Letter G, I'm going to move h out of the way first, just so I have space. Letter G, this gives you 4x plus 6 from distributing. Ooh, we got some combining like terms. You got a 1x and a 3x gives you 4x. Plus 5, and then we subtract 4x on both sides. This and this cancel, and 5 equals 6, which is not true, so this is no solution. Letter H. Nothing over here. Oopsie. Nothing on the left. On the right, I can distribute. give me 4x plus 20. And then I actually have a little bit of simplify, because I've got this 20 minus 1. I can pretty that up. 20 minus 1 is just 19. And then I would minus 4x, and you have 19 equals 19. That is true. So this problem is all real numbers. This is the solution. All real numbers. No matter what you plug in for x, both sides will always be true. You will always get the same thing. So every number is an answer. So let's get some applications. So example 3 says find the perimeter of the square with a given side lengths. So it wants us to find the perimeter. So you think back, okay, perimeter of a square. A perimeter of a square, well, you'd add the 4 sides together. So you could say like 2 lengths plus 2 widths, which is actually the formula for the perimeter of a rectangle. For a square, since all the side lengths are the same, you could say the perimeter is 4, whatever the side length is. Well, I can't just plug this guy in there, because the problem would be if I plug in one of these side lengths. I mean, essentially they should be the same because it's a square. So if I plug one of these in for s, perimeter equals 4 times 5x minus 9. And I would distribute, I would get 20x minus 36. The problem is, I still have 2 variables. I have a p and an x. What I'd like to do is I'd like to be able to figure out what this x is. Because if I could say, play pretend, if that x is like 3 or 5 or 12, whatever it is, if I could plug that in, and then I could do the math and make this become a number, and I'd have like perimeter equals whatever it is, say 50. I would like that to be true. But in order for us to do that, we need to find the x value so we could plug it in. Or even plug it in up there. So my in-between goal, my final goal is I want to find the perimeter. So my kind of midway goal is I have to find what this x value is. Alright, so the only information they give me that has x values are this and that. Can you figure out how to find the x value from that? I'll give you a hint. The hint is, it says that this thing is a square. Does that help you out at all? What if I told you that a square, the special thing about squares is that the side lengths are always the same. All the sides have the exact same length. Well, if you didn't get it from those hints, I might as well just come out and tell you. Because it's a square and the side lengths are the same, that means that this side is the same as this side. And in terms of math, the same, 2x plus 3, is the same as 5x minus 9. Look what we got there. We have an equation with variables on both sides that we can solve. So let's solve this. If I subtract 5x here and subtract 5x here, I have negative 3x plus 3 equals negative 9. I minus 3, negative 3x equals negative 12. Divide both sides by negative 3, and x equals 4. So I found the x value is 4. That is the one piece of information I needed in order to find the perimeter. So with x equals 4, I could actually plug a 4 in right here. If you kind of followed along with this, watch this. 20 times 4, it's 80. 80 minus 36, 80 minus 36 equals 44. So we think that's the perimeter. If you did it this way, it works. It's actually true. If you didn't do it this way, if you just kind of looked at the shape and said, okay, well, now if x is 4, that means 5 times 4 is 20. 20 minus 9 is 11. 2 times 4 is 8. 8 plus 3 is 11. All of the side lengths are 11. So to find the perimeter, 11 plus 11 plus 11 plus 11 is still 44. That's why this is a DOK2, because it took the extra steps of finding the x value first before you could find the perimeter. You have to do that extra step. Here's one for you to try. It says, what is the area of a triangle if the area is represented by 3x plus 2, the base is represented by 4x minus 8, and the height of the triangle is 6 inches. The formula for the area of a triangle is area equals 1/2 base times height. So pause the video right now, try this on your own. You're ready to continue, hit play, and we'll go through it together. Alright, so the first thing I do is I'm going to draw myself a picture, because I'm a picture guy, I like pictures. Doesn't even say it's a right triangle, does it? No. But actually, I'm going to make it a right triangle, because it helps with my base times height in my head. Alright, so the base of this triangle is 4x minus 8. The height of the triangle is 6. And the area of this triangle is 3x plus 2. Alright, so I have now just kind of drawn a picture. I plugged in the information it tells me in the problem. Base is 4x minus 8. The area is 3x plus 2. The height is 6. Okay. So it wants me to find the area of this triangle, meaning it wants a number. It wants like area equals 45 inches squared or something like that. The only other information it gives us in the problem is it gives us this formula, which I think is going to come in handy, because watch this. If we take the area equals 1/2 the base times the height, I know, or I could plug something in for every single one of those variables. I know that the area is 3x plus 2. I substituted. 1/2 is 1/2. Yeah, I'll leave it as a fraction, I guess. I was trying to decide if I want to leave it as a fraction or a decimal, but fraction's fine. I know the base of the triangle is this 4x minus 8. And I know the height of the triangle is 6. So let's see if we can solve this. I believe we can. I only see two variables that it's the same variable. I don't see anything too terribly ugly in the problem besides just some of this math. So let's see if we can find out what this x value is. Well, 3x plus 2. Oh, I see over here. I need to do some simplify. I've got 1/2 times this stuff times by 6. So let's take 1/2 times this stuff. So half of 4 is 2x. Half of 8 is 4. And this is all still times by 6. And that stuff stays the same. And now take this and distribute this way, times by 6. I get 12x minus 24. Alright, now we're cooking on all cylinders. I got everything simplified. No more parentheses, no more combining like terms. So we're going to subtract 12x, get rid of the variable on the right. He cancels. Oopsie, not 24. Or negative 24. There we go. And this gives me negative 9x plus 2. And let's see, I'm going to subtract 2 on both sides, give me negative 9x. equals negative 26. I do everything right? I'm just double checking my math. Half of 4 is 2. Half of 8 is 4. 6 times 2 is 12. 6 times 4. Oh, that looks okay so far. Divide both sides by negative 9. And I get x equals this kind of ugly fraction. So our answer is actually just going to be this 26 over 9. I should say that's what the value of x is. And yeah, it's kind of ugly, and that's why I went back and checked my work for possible mistakes. And there were none. Now, we're going to take this, and we can use this to find the area of our triangle. This is the formula right here that's going to help us out. Because it says the area is equal to this stuff. And since I know what this x is, if I plug this 26 over 9 in for x, I get my answer. So area equals 3 times 26 over 9 plus 2. And yeah, I'll leave it like that for now. So let's see, I need to multiply this. So 3 times 26 over 9. 3 over 1, 26 over 9. That gives me, let's see, clear here, we got 3 times by 26 is 78 over 9 plus 2. I'm just curious, what's 78 divided by 9? So that's 8 and 2/3. This decimal expansion, 0.6666666, and that's rounded. That decimal expansion is 2/3. So this simplifies down to 8 and 2/3. If I do 78/9 this way, simplify, 8 and 2/3. I think that's just going to be a little bit easier to work with. So area equals this is 8 and 2/3 plus 2. Add the whole numbers together, area equals 10 and 2/3 inches squared. So the area of this is 10 and 2/3. I honestly would still maybe rate this a DOK 2, not a DOK 1. It's a little bit difficult. You had to solve an equation to find the value of x. You then had to take that value of x and plug it into an equation to find the solution. So this is solving equations, variables on both sides, some applications. A lot of the applications are going to be geometric, with squares and triangles and rectangles and things. Okay, so for our summary, we have a type 2, so take your time to get a good correct response because I'll be grading your answer on the correctness of your response. How can you tell if an equation will have one solution, no solution, or all real numbers as a solution? So throughout the lesson, we talked about this. When there will be one solution, when there will be no solution, or when there will be all real numbers as a solution. So think about your response, write it down, give a nice response, pause the video if you need the question a little bit longer. If not, it's been lesson 4.3. Thanks for watching.